Thank you for joining the Oscar workshop. So we give it this name, Open Source Core Applications and RAN. And the main motivation to organize this workshop was to get an update from different organizations. Actually, you have them here. OpenAirInterface, Free5GC, srsRAN, and Open5GS, and 5G Mac reference tools. So we wanted to get an update from different projects working on open source tools in relation to communications, in relation to networks, 3GPP standards, and so on. And the main idea was to, first of all, and you see this in the agenda below, so if you go to our website, everything is here. So we would like to get an overview of the different projects run by the organizations, by the 5 organizations that are joining this workshop. And then we would like to dig into some details in terms of implementations, availability of open source software in relation to, and we have put here 4 topics. So one is the 5G core implementations, and for this we have Open5GS, Free5GC, and OpenAirInterface doing work. RAN implementations, which are in the scope of srsRAN and OpenAirInterface. Then OAM with OpenAirInterface, giving a presentation, a brief introduction on these topics. And then, as 5G Mac is mainly dealing with multimedia implementations of the 3GPP standards, but also within the wider ecosystem of MPEG and IETF and other standards that are interrelated, we wanted to give an overview of our work and then have opportunities for discuss, collaborate, next steps, and basically to understand a little bit what everybody's doing and move forward. Feel free to send your questions over the Q&A or the chat, right? We take the workshop quite informal, and the idea is to, let's say, trigger collaboration and to try to reply to the questions, to the anything that expose your curiosity. So without further ado, I would say let's get started, and then we start with an introduction of the different organizations involved here, and we start with OpenInterface. And actually, I would like to welcome Robert Smith from the OpenInterface Software Alliance to give us an introduction of OpenInterface and a little bit how you work, how you structure the project, a little bit like the overview of the organization. Robert, the floor is yours.
Hello, can you hear me?
Yes, we can.
Okay, and I have a couple of slides. I hope they will do justice to what you asked me, where I go a little bit over, well, OpenAirInterface as an organization, and well, then briefly to give a very brief overview of the different project groups that we have, and they will have the individual presentations later, so not too much detail, but nevertheless, I want to give you the full picture. So I try my best to do it also in 10 minutes. What is OpenAirInterface? I mean, maybe many people here have heard about OpenAirInterface. So it's end-to-end 4G and 5G RAN and core network software, or that's at least, let's say, the basis. So it started in 4G days and actually even before. Nowadays, for 5G RAN, there's the GNLB, the UE, then the core network. We will hear it from Teen, and then as you see later, there's also operation and management and so on. Yes, everything running on commodity x86 or ARM hardware, or also cloud infrastructure, then interfacing with various software-defined radios, also commercial radios. So the 7.2 front-hole split is very popular these days, right? The goal, the objective of OpenAirInterface is in general to be 3GPP and ORAN compliant. So, I mean, the official things say something around the reference implementation. So being a reference implementation for 3GPP implementations and also ORAN, and then, as I said, augmented by RAN control, operation and management software. So there we come to the RAIC and O1 interfaces and so on. I want to talk a little bit about the organization from a high-level point of view, and maybe also clarify a little bit what sometimes gets confused, so to say. So there is Eurocom, and maybe I've also seen, or Tini will say, he is an Eurocom employee. So Eurocom is an research institute in the south of France, close to Nice, and this within this research institute, they initially started to develop OpenAirInterface as an implementation, I think in the beginning even 3G and then 4G software. And in order to further sustain these activities and not have it only run by the researchers that work in Eurocom, they founded in 2014, so more than 10 years ago now, the OpenAirInterface Software Alliance. So the OpenAirInterface Software Alliance is a non-for-profit that is separate as an entity from Eurocom, so to say. We are physically located in the same building, so there is a close partnership between these two, Eurocom and the Alliance. But yes, nevertheless, it's now the Alliance is the home of OpenAirInterface, so to say. Often the question comes up, how is it financed? So you see on the right a couple of logos for the what is called the strategic members, so the company that finance the OpenAirInterface Software Alliance and support it financially and also in other ways. And the OpenAirInterface Software Alliance mission is to facilitate OpenAirInterface adoption and is generally responsible for development roadmap, quality control, and promoting software packages and so on. One thing that I want to mention, so we are in a sense maybe expanding. So very well recently, earlier this year or end of last year, there was a new US-based entity that has been funded, the so-called OAI Foundation or OpenAirInterface Foundation. So that is a foundation that will run alongside the OpenAirInterface Software Alliance. And yes, being built up right now. So we are hiring if there are some people who might be interested into maybe joining either in the US and in the US remotely, or maybe also in France. That's also a feasibility. Yes. So, the current major topics, maybe now that's relatively clear already from what I've said before, but full stack 5G GNode B, the UE and the core network, and within there, the Open RAN splits. So, all the various splits that we can have and interfaces, including E201 and so on, cloud native deployment, so that we can deploy this in various infrastructures. One major goal there, third-party interoperability, hardware acceleration, which we'll see in some of the presentations later, and then of course near real-time RIC and OEM, as I have already said, and next-gen readiness. Maybe to just give you a picture about the Alliance. The Alliance is actually not that big. There are only around 10 full-time staff that work for the Alliance, and this means mostly developers, but also some management, some marketing, and general accompanying services, so to say. There are a couple of contracting engineers, and the budget, you have it also on the slide, the yearly budget. So I already mentioned the OpenAirInterface Software Alliance is structured in different project groups. So the first and maybe also the biggest is the 5G RAN with GNode B and the UE with various simulation tools, all these 3GPP or run small cell forum interfaces, acceleration, and so on. The second project group is the core network, so which is everything around the core network, the service-based core network, and different network functions. And here, a lot of these projects, of course, are also contribution-driven, and the core network is mostly driven forward actually by Eurocom. I should also say this. So the RAN, very much for the Alliance. The core network, the biggest part comes actually from Eurocom. There is then the smaller operations and management that is concerned with near real-time RIC and E2 agents, so the project called FlexRig, which we'll hear later. Also the O1 interface to then via O1 connect to service management and orchestration. And finally, in a sense, maybe the smallest but nevertheless very important group is CI/CD, so management of the different test beds, testing automation, providing container images, and so on. So then there was some question how to work with the OpenAirInterface of Alliance. So I have here one slide, but I think that is more like um, destined to companies. So typically when we talk, like they need to have a vision, and then typically they get a seat on the OSA boards, and they would also have voting rights, and then they can have a say in the administration and future orientation. And of course, then they have some influence on where money is spent, and then they can define strategic projects and maybe also drive in a specific direction. If it comes like more to smaller contributors, typically I think how this works is that you will start to contribute maybe some bug fixes or some smaller features, and then you grow within the organization. I would say that's maybe relatively natural. Yes. Also, in general, what I want to say here is if there's ever somebody who wants to contribute, but they don't know how to contribute, there are two options. Either they write to me, even on LinkedIn, if they don't know where. There's also an official contact at OpenAirInterface.org email address where you can always write, and then you should get an answer. So we are typically also, as the Alliance, present in a number of events and have some relations. So we do workshops, we do hands-on training in various places. So the last workshop was a couple of weeks ago in the Ericsson headquarters, actually in Kista, close to Sweden. This we do bi-yearly typically. We are typically also present in Mobile World Congress in the various ORAN face-to-face meetings and so on. Yes. The Alliance also has signed a couple of agreements with various organizations. So, for example, the ORAN Alliance, also the Linux Foundation. And I also want to highlight that there are some ties with the Small Cell Forum to further the FAPI work. So one of the questions also upfront was the licensing model. So I just want to briefly highlight. So most of the software that is within the Open Interface Software Alliance, so I mean, especially when we talk about 5G everything, is licensed under the OAI public license. This corresponds to a modified Apache version 2 license. And well, as said, it's augmented with an upfront clause for patent license. So I don't want to go too much into details. Maybe here I can also refer to the last workshop. There was actually a presentation on that. You might find a bit more detail. But in general, the license grants everybody a free license to use OAI for all purposes for study, testing, and research. So this also includes research labs, universities, and in particular also companies. So like research definitions and so on. And then the afferent clause refers to an additional clause which actually makes it acceptable for the general 3GPP contributor community. So for all the companies that actually have patents within 3GPP to then also contribute to OAI or the alliance in general without infringing or giving up their standard essential patents that they actually have in 3GPP. So that's what this afferent clause refers to. So, but nevertheless, once more, for research labs, university students, research definitions and companies, if it's for study testing and research, it's completely free. And also the Alliance won't ask anybody for money. So the final thing that I want to highlight, so there, of course, now OpenAirInterface, as I already initially mentioned, is or supposed to be used as a reference design to then build use cases further, testing, maybe also products. And this also makes it very suitable, of course, to make use cases in the realm of 5G and beyond 5G 6G research and testing. So also under that angle, it's quite centrally positioned in the next generation research group at ORAN. And yes, in general, we are very open. So if there are use cases or things that people want to test, then we would like to ask you to reach out and further in these different domains. And with that, I think I'm now exactly 10 minutes. So I thank you for the attention. And if I've understood well, the questions, they will be asked during the presentation or maybe at the end. So I give back. I thank you a lot.
Robert, thank you very much. Yes, so we are collecting questions over the chat as we compress this first introduction. Feel free to answer. I see Camille already answering the questions on the chat. Feel free to send us more questions, and then I believe there will be time later on to understand a bit the developments on the 5G, on the 3GPP specs as such. Thank you, Robert. Let's jump then to the next organization joining the OSCAR workshop. It's srsRAN. And I believe we have Brendan in the call.
Hi, yes, can you hear me?
Hi, Brendan. Yes, please go
Hi,
ahead.
guys.
Yours.
I will just take over the screen here. Okay, so just a quick introduction of myself. So my name is Brendan McAuliffe. I'm the Technical Communications Manager here at SRS. And so, yeah, just going to give you a brief walkthrough of SRS as a company. And then later in the session, a little bit more of a technical deep dive on srsRAN project and what it is. I just want to check, can you see my screen?
Yes, we can.
Okay, great. Fantastic. So SRS is a private company founded in 2012. We're headquartered in Ireland. We have offices in Ireland and Spain, and then we have employees distributed in both Ireland and Spain, and then remotely throughout Europe. So currently we're at about 27 full-time employees, and we are 100% software radio, 100% organically grown. We're bootstrapped. We're not funded by anybody, and we're pretty much all engineers. So we all have an engineering background, or at least are all interested in engineering. So we have kind of four main areas of expertise and areas of focus as a company. So obviously software radio and telecommunications, and then software engineering and signal processing. So we leverage all four of these areas to create our products, which are srsRAN project, which you'll all know. So this is our open source offering, which is a fully open source 5G ORAN compliant CUD solution. We also have srsRAN Enterprise and NTN 5G. So this is essentially at its core srsRAN project with some enterprise features plugged in on top. We also have a UE solution for this as well. Then on our 4G solutions, we have srsRAN Enterprise 4G, which is our 4G 4G eNodeB and UE solutions for commercial customers. So a little bit on how we license the product or the products. So we use what we call kind of an open core approach to our design, and then we have dual licensing. So we license srsRAN project under AGPL v3, and then our commercial products are licensed on a more ad hoc basis. So the commercial licenses are tailored to the needs of the use case and the customer. So we have the typical commercial licensing. We also have academic and research licensing for srsRAN Enterprise. What's good about this is that it allows us basically to offer our open source users a commercial deployment ready grade product. And our commercial customers then also benefit from this open source approach as their commercial product is basically vetted by our large community. So this is kind of a synergistic relationship between the two, which means that open source is benefiting from commercial and vice versa. In terms of commercial engagements, so we have a large engagement with AST Space Mobile. So we're responsible for helping to create their direct-to-device mobile network for 4G and also assisting with their current investor demos. So the initial proof of concept network was built using our stack, and we hold a few patents on that to allow the network to work. And we're still involved with them now in doing some further testing. We also have multiple air-to-ground deployments in the US. So we have 3 unique engagements currently ongoing across private and military applications, and we have 2 large-scale network deployments with that. In terms of live deployments, we have over 50 live deployments of srsRAN Enterprise. Again, as I mentioned, this is basically the same code that is shared with srsRAN project. And then we have live NTN deployments with AST Space Mobile. We're also involved in multiple publicly funded projects. So these are the Horizon projects, SNSJU, PTE here in Spain, and some other publicly funded projects across the US and Europe. So the main ones at the moment would be Stardust, Trantor, 6G Leader, Unity 6G, Nexusphere, and Saturno. And within these projects, we typically act as the platform provider. So that means we go in with srsRAN, so that could be srsRAN project or enterprise, depending on the needs of the project. And then we will assist the consortium members in modifying the code base as they need based on the use cases of the project. So that's it for the introduction. I hope that's given you a better overview of who we are as a company, maybe help to separate SRS from srsRAN project. I know a lot of people know the code base, but maybe don't necessarily know much about the company behind it. So I'll leave it there, and I'll be back shortly with more information on srsRAN project.
Thanks a lot, Brendan. We keep getting questions over the chat, so please use to srsRAN, and then we collect all the questions and comments to Brendan. Let's move on quickly to Open5GS, and for this we have Suchan Lee joining us.
Yes, I'm here.
You are
Can you
here.
hear me?
We can hear you, Suchan. Just go ahead. Welcome to the call.
Okay. Okay. Can you hear my screen?
We can see your
Can you
slide.
see our screen?
I can see your screen and I can hear you, Suchan.
Okay. I'll go ahead. Yeah. Uh, Thanks for joining this session. I'm Saktan Lee. I started Open5GS as a personal project a few years back. Today, I'd like to share what we've built and learned along the way. I'll try to cover the technical aspects, the project structure, and honestly, I'm still amazed by how supportive our community has become. When I first started coding this, I never imagined it would grow into what it is today. So back in February 2017, I was just curious about how mobile network actually work under the hood. I started writing code from scratch, purely as a hobby, no funding, no grand plan, just me trying to figure things out. It took about 10 months of evening and weekend to get something working. Uh, I was just lucky to have Jihoon and Jinyoung helping out during those early days. When they decided to pursue commercial route with Next EPC, I kept the open source version going open 5GS. Adding 5G support to 2020 was well. Let's just say, yeah. And then uh, what we ended up building is a system that handles both 4G and 5G network. Uh, I tried to make it modular from the start because honestly, debugging telecom code is nightmare. Uh, the architecture include the standard component you'd expect, AMF, SMF, and UPF. We support user protocol like HTTP/2, TLS, PFCP. Nothing revolutionary, just trying to implement the spec and make it actually work in practice. Uh, from a developer perspective, I try to structure things the way I'd want to work with them. We have shared libraries for common stuff like core function, security, and protocol handling. Each network function has its own directory. Makes sense at least to me. The 4G integration came from necessity. People need to migrate gradually, not to a big bang replacement. Security was something I was probably paranoid about at the beginning. And so implementing TLS and everywhere and feature like sushi protection, yeah, something like that. I have to say, our community really surprised me. We use GitHub for user bug reports and feature requests, which works well enough, but the Discord server has become something special. People help each other out their way more than I ever expected. I try to jump in when I can, but honestly, the community often knows the answer better than I do. It's become this place where telecom engineer, researcher, and curious developer all help each other figure things out. These numbers still unreal to me sometimes, yeah. I've made most of the commit. That's what happens when you start a project from scratch and spend 8+ years on it. But having 95 people contribute code, documentation, and bug reports. The licensing model wasn't something I planned from day one, but it evolved as the project grew. AGPL v3 works well for researcher and open source projects. You can use it, modify it, just share your improvements back. For companies that need proprietary modification or can't work with copyleft license, we work with partners to provide commercial licensing. It's not the most elegant solution, but it seems to work for both keeping the project sustainable. I'm fortunate to work with some great partners who understand both the technical and business side of this. The plane is focused on commercial licensing and enterprise support. Next TPC bring high performance implementation with TPDK acceleration. And Sysmocom has deep expertise in open source telecom. Thanks for listening, and especially thanks to those joining online. I'd love to hear your question or idea, where you're just curious about how this stuff works. Thinking about using Open5JS for research or want to contribute to the project, feel free to reach out on GitHub or join on our Discord. Thank you.
Sukhchand, thanks a lot. I think my question would be, how can you deal with all of this, right? With all these commits and so on. Please, let's get questions on the chat. Thank you, Sukhchand, and we come back to you in a few moments for the 5G core. Let's go quickly then to the next presentation. It's from Free 5GC, who is joining us, Professor Chen.
Hello.
So, hello, welcome to the workshop, and the floor is
Yes.
yours.
Yeah, let me share my. Can you see me?
Yes, we can hear you, and your slides are also showing.
Okay. Okay. Yeah. Yeah. This Free 5GC. This is a university project. I'm a professor at the Department of Computer Science in the National Yangmin Chiaodong University, located in Hsinchu, Taiwan. Um, National Chiaodong University actually is established 100 years ago, and they re-established in Hsinchu. Uh, our university mainly focus on electronic engineer and like computer science. So like TSMC CEO from one of our alumni. So a lot of tech company in Taiwan, the CEO and founder is from our university. And basically, just 5 years ago, we merged with one of a medical school in Taiwan. So now we call National Yangmin Chiaodong University. Okay, that's how it's our background. And of course, this university project, so we actually getting help from like a National Science Technology Council, like pretty much like NSF in the US. And we also got support from Ministry of Economic Affairs and Ministry of Education. And we are in the Department of Computer Science, so we have a lab we call Communication Service Software Laboratory. So we have multiple professors involved in this project. We have people doing the security, people who's doing the cloud native, and people doing the testing, people doing the AI. So it's a loose couple kind of lab, and so we actually our students work together to create Free 5GC. So a little bit history of Free 5GC, and basically Free 5GC is the world's first open source 5G core network that comply with CGPP 15 standard. And of course, we start this core network research and development at very early in 2016. In that time, there's no 5G standard yet, but so we actually implement 4G with a 5G kind of concept. So we have a version of 4G with some 5G concept, or we call an SLV. And then we actually start to the company who are interested in non-standalone 5G core network. So we actually implement one for a proprietary only for one of company in Taiwan. Then 2019, we decided to have the free 5GC, which is a standalone and which comply with 3GPP release 15. Because we are university institute, so our students keep working on different topic of release 16, 17, and even 18. Now we're also working on NTN and UAV non-terrestrial network as well. So yeah. So just last year, September 16, we decided to move to Nini Foundation, provide open source alternative across 5G deployment. So since that, then we are under supervised by this Nini Foundation. So our free 5GC complying with 3GPP TS release versions 15.3 and beyond. We are Apache 2.0 license, which means you can just download it, you can change it, you can keep it. And currently, our free 5G is release 4.0.1, which include release 17 open API. So how we test our free 5GC? We using commercial base station and UE, for example, Nokia OpenAirInterface. And because in Taiwan, a telecom company, special for this small cell company, is they actually provide us their commercial small cell to interworking with our core network. So we have been lucky to have ASCII, ATC, Pekatron, Combo, Alpha, WNC, those companies which provide us their commercial ORAN or commercial small cells, so we can interworking with our core network and UE as well. And also because we are open source, people who are testing uh, in like people will report our free 5G, see how to work with like Huawei P440, 5G UE, and Amsoft, they will report to us, so we know which device can be interwork with our free 5GC. And we also to license like a commercial test tool, like a Spirent Lens Light, and in order to obtain the performance testing and with many UE and RAN. And we, of course, some professor working on the black box testing or gray box testing. And Free 5GC currently performance is about, I think this has been, performance has been major, maybe it's not a recent release. This as 1 year ago data control plan. Basically, you have 20 attachment per second. You can have 1,000 simultaneous action user, and you can have a 5,000 register user. But I think the number is increased now. The user plan, you can have 800 megabit per second or 10 gigabit per second. Of course, highly depend on hardware. And this is last 14 week, 14 day download and viewer. This is roadmap for last year roadmap. So we have like OOS 2 has been released, charging has been released. And then we have doing some network function refactory, and basically we have a hem chart for free 5GC. We have web console profile for free 5GC. Then we have release upgrade to release 17 Open API, and we are working also on many different uh, uh, release 16, 17 standard, but it's more on this research basis. We need to clean the code and try to put it on our branch later. Okay, I think yeah, that's about what P5GC is.
Thank you very much, Professor Chen. I think that's been really useful also to include the roadmap. So let's get questions for free 5GC over the chat, and then let's move to the next presentation. In the meantime, I insist, people can send their questions on the chat, and then we can answer them offline. If there is time later on at the end of the workshop for online questions, we may take them, but please continue populating the chat with your questions. All right, so I'm gonna grab the screen now. It's actually my turn. It was actually Daniel Silhavi who was going to present. However, he is not available, so I'm going to share and present for 5G Mac and the 5G Mac reference tools. So basically, to start with, just let's say a presentation of what 5G Mac is, right? So we are an industry association, and our role is in driving standards for connected media experiences. Actually, we foster collaboration on the actual implementation of let's say connected media applications, services and applications that are powered by open standards, 3GPP, MPEG, for instance, and we drive an open source community, which is more or less what we are going to talk about today. The work in 5G Mac is structured around three pillars, I would say. One is pre-standardization, right, where we collect requirements from the industry and try to provide a consensus view on them towards SDOs. For instance, we've recently participated, we have been actually participating in the different workshops organized by 3GPP, release by release, in order to provide input, and also recently on the 6G IMT 2030 workshops as well. However, the main core activities in the association are around the standards and software development, so what we call standards and post-standardization. We are actively supporting the standards work by means of, for instance, providing feedback from the reference implementations that come from our software or open source software program, 5G Mac reference tools. And we also use these reference tools first of all, to show the industry how the technology can be applied to specific, let's say, applications and services. As said, to provide feedback to the relevant standards organization, developing these features and tools, but also, let's say, to power trials, demonstrators, right, and to reach out to the wider industry. So let's jump directly into software, right? So the idea behind the 5G Mac reference tools development program was actually to, let's say, to support the industry with reference implementations and to show or to provide tangible results or tangible assets that the industry can take in order to ideally develop pre-commercial prototypes, right? Or at least to move technology towards products. Not to stay just in a let's say just in the standards phase or even in the research phase, but to actually move technology into commercialization. So the 5G Mac reference tools support the validation of standards, asset demonstrations, testing. It's a shared development effort. So basically, the efforts put into the coordination of the 5G Mac reference tools come from 5G Mac via the membership fees, right? Which is our income, let's say. So we put efforts according to members' priorities and little bit also it's all contribution based, but according to the priorities and the roadmaps specified by the 5G MAC members, we support the implementation of standards and tools. The code is ready to use, right? And what we want to do is also to provide like certain building blocks enablers so that you can build your application. And for this, and we will see later on, we use some of the tools that actually the other presenters have put on the table, right? So for instance, we are using srsRAN, we are using Open5GS, and we are open to use, let's say, any different modules, network functions, and so on available by any project, right? Our intention is to show technology or to show technology, let's say, approaching products. And we believe that by means of these open source development communities, where we allow for transparency, trust in the code, I mean, people that want to collaborate really have a place to collaborate. And well, you can see this from the different commits, issues raised in GitHub, and so on. So I won't provide many more details, but for instance, here you have an example of how we track feedback from the developments and how we ingest them into, for instance, 3GPP SA4 group when it comes to multimedia applications. So we collect the feedback from the developers, ideally if we develop within the same release, so that we can attach this feedback to an open work item in 3GPP and actually help, let's say, the making of the specifications to detect bug fixes or even to request new features, right? So we would like to get this kind of more direct impact into the standards. As said, the development and the community is open to the industry, academia, independent developers, right? But the roadmap and prioritization of topics and also the, let's say, the efforts in terms of resources for coordinating the activities come from 5G MAC members. All of this is available in different places. So you have GitHub, obviously, for all the repositories, and we are also building, and it's a big effort, or let's say it's consuming a lot of time from our side. We are building documentation, right? Because the tools or the software without appropriate documentations, tutorials, how to use the tools, how to install, build, and in the end, how to play with them, it's essential also for lowering the barrier from the industry to get access to the technology, to the tools, and in the end know what to do with them, right? Because it also the amount of repositories grows and grows. In addition to GitHub, where we manage, let's say, feedback with the issues and so on, we have a developer community based on Slack that anybody can join, where, let's say, we discuss among developers, right? So we try to provide support, and we interact, or it allows to interact, chat between developers. It's quite active. At the beginning, we were not sure if that would work, but it's working daily. So there's a lot of activity. There's more activity in 5G MAC in Slack and let's say GitHub and so on than actually on our internal platforms. We have also a mailing list which is managed by Google Groups, where we announce releases, and well, people can also ask questions there. And another thing we set up recently was a public call. It's the last Friday of the month. It's a public call where people can join. We invite also presentations from other projects in order to reach out, right, and to get insight also from the wider community. So these calls are open and everybody can join. This is an example of what is available in terms of tutorials. So we insist, let's say, and we encourage developers, let's say, not only to do the code or to develop the code, but also to make visible their efforts. And for this, we have videos in YouTube, tutorials, and so on, where they can show actually what they have been developing and how it works, right? That also supports a little bit like moving the tutorials into something more audiovisual. And then we also, let's say, show these efforts attending, for instance, demos at Mobile World Congress, at IBC, and any, let's say, relevant event for media technologies that we feel it's worth attending. In terms of the technology itself, and we will move, I just want to provide an overview, but we are working in general on 3 topics: connected production, which is more like the uplink case, right? Producing content and so on. Within the scope of this track of work, you can find on public networks, also TSN, 3GPP media delivery, APIs, right? So we have some analysis now going on in 5G on APIs from 3GPP and Camara. In terms of media delivery, there are different aspects: 5G media streaming, 5G broadcast, MBS. NTN is also a topic I've seen it's been mentioned already. And then on the pillar of immersive media, at the moment we are following the work, or we are supporting the work in 3GPP in terms of XR media integration in 5G. We also have work in relation to MPEG to support this on the MPEG ISIN description, which is the standard, let's say, adopted in the 3GPP standards also. And we are also hosting some tools for volumetric video based on MPEG v3c, and this is related also to a 3GPP feasibility study on beyond 2D media. And well, when it comes to the actual tools, right, to the actual code, this is what you can find, right? So we have reference implementations of 3GPP systems, MPEG, there's relation also with Dash, IETF, Chronos Group, and so on. And you can find the tools in our GitHub for different specifications from 3GPP. For instance, 5G media streaming architecture, some components of the 5G core that actually are built on top of Open 5Gs. We have reference implementations of UE data collection, reporting, and event exposure, and other tools that you can find here. I will just move on, and we can talk about this later on. When it comes to the license, we follow a very similar approach to OpenAirInterface, right? So we want to encourage contributions, and then we need a license that allows, let's say, companies with relevant IPR portfolio to contribute, right? Because if not, well, we are lagging a little bit, like the standards people also contributing, right? Or the companies behind the standards also contributing. And I think this worked. I mean, it worked for OpenAirInterface, and we thought it was a really good model. So you have the details on 5G MAC license. And then these are the official contributors that have signed a CLA and that are actually able to contribute code to the 5G MAC reference tools. And I stop here. I'm happy to take questions in the chat. And later on, we go a little bit more details on the actual implementations, specifications, and so on. With this, let's move on then to, let's say, to the actual work, right? To the actual code. And I believe the first, let me go back on myself here to the agenda. We are going to cover first the 5G core implementation, just to understand a little bit where the different projects are. We are good in time, despite the delay at the very beginning. We go for 5G core implementations, and the first presentation, I believe, comes from Open 5Gs. Suchan, I think you need to leave a little bit early today. So we would like to hear from you about well, your 5G core implementations, where you stand, what you have developed, let's say in terms of releases, in terms of also next steps, and so on. So feel free to present and give us some details on the 5G, on the Open 5Gs implementations for the 5G core.
Okay, let me share my screen. Oh, 1 sec.
Sure. Yes, we see your screen now.
Oh, wait a minute. Ah. Yeah. Hi again. Thanks for sticking around for the technical session. I'm back to dive deeper into what we've actually been building in Open5GS. Since this will be my last chance to take lesson today, it's getting pretty late here in Korea, and my kids need to sleep. Please feel free to ask anything during or right after this presentation. Let me walk you through some of more technical stuff we've been working on and where we are headed. So let me start with what we've actually managed to get working recently. These took way longer than I initially thought they would, but I think we got them right. The HTTP/2 over TLS support was necessary because 5G really moved away from diameter heavy approach of 4G. Getting the TLS part was tricky. Sorry. You need different certificate and different scenario, especially when operator needs to talk to each other securely. The sushi implementation was something I felt we really needed. In 4G, if someone captured your SONAP traffic, they can potentially see subscribe identities. Sushi encrypts that, which feels like basic privacy protection these days. UPF high availability was probably one of the most complex pieces on the data plane side, making automatic failover work reliably when UPF instance fail took a lot of testing and debugging. There are so many edge cases when network components fail suddenly. PFCP restoration is the complementary feature for handling peer PFCP entity failures. PFCP is the 3GPP protocol used between SMF and UPF, and between SCWC and SGWU. We implemented the heartbeat mechanism using PFCP heartbeat request and response message to detect when peer entity fail or restart. This allows those to properly handle session state and restore connectivity without losing existing user session. Getting the timing and state management right was tricky, but it's essential for network resilience. And the framed routing support came from user requests for IoT scenarios, where one device needs to provide connectivity for multiple IP range. Pretty useful in practice for complex IoT deployments. The Prometheus integration was something a user kept asking for, and honestly, I should have done it earlier. Monitoring is crucial if you want to learn this stuff seriously. We built generic metric API using Prometheus client C, so each Open5JS process can serve metrics sort of a simple HTTP endpoint. Nothing fancy, but it works well with existing monitoring stacks. You can easily hook it up to Grafana or whatever monitoring setup you already have. The tricky part was deciding where metrics actually matter and not overwhelming people with too much data. We tried to focus on the metric that would actually help you understand what's happening in your network. SAPP was probably our biggest architectural challenge. It's basically the secure gateway between different operator networks. But the tricky part is that when we first designed Open5J's 5's core architecture, we didn't have SAPP in mind. We had to rethink how network functions discover each other and route messages. It wasn't just adding another component. We basically had to redesign the service communication model. TLS is mandatory for the N32 interface between operators, but internal communication can stay HTTP for efficiency. Getting the certificate management right was, let's say, it took several iterations. Operator needs to be able to trust each other's certificate while maintaining security isolation. The old configuration system just couldn't handle the complexity we needed for roaming and SCPP. I had to basically throw it out and start over. This new format might look complicated, but it gives operators the flexibility they actually need. You can see how we can set up different TLS certificates for different interface and configure defaults that make sense and handle all the T32 interface requirements. I know it's more complex than the old system, but real-world deployments need this kind of control. Different interface, need different security setting, different certificates, different routing rules. The old system was too rigid for that. Roaming brought some really interesting technical challenges that aren't obvious until you try to implement them. First, how do you route message between operators? We use FQDM-based routing, where each network function includes the operator's PLLM ID in its domain name. Sounds simple, but getting all the edge cases right took time. The bigger challenger was figuring out if subscriber is roaming, especially for SMF is local breakout scenarios. In AMF case, AMF gets the SUSI, which clearly indicates the home network, because SUSI has the PLLM ID, but SMF only gets the IMSI. The problem is some mobile country code use 2 digits, others use 3 digits, and you can't always tell just from the IMSI. Our solution uses full DNN. Basically, the complete domain name includes the operator identifier. It works reliably when everyone follows this approach, full DNN, but it might cause interoperability issue with implementation that don't use full DNN. There is an alternative approach using PLLM database, but for simplicity, we went with full DNN. This complexity doesn't exist home routed scenario, which is why there is often the simple route deployment option. Right now, we are focused on finishing up home routed roaming. The development is done, but I'm being careful with testing since roaming is one of those things that needs to work reliably. And next, UPF performance is obviously something I'm not entirely happy with yet. Our current implementation works, but it's not going to compete with specialized high-performance solutions. We are looking at eBPF XDP to improve our existing UPF, or potentially integrating with other solutions like eUPF or UPG VPP that are designed for performance from the ground up. Release 18 features are also on the roadmap. The 5G specs keep evolving, and we are trying to stay current with important capability that people actually need. The roadmap is what we are aiming for. So as any developer knows, timeline can be optimistic. Q2 should see home routed roaming after we finish testing. They'll complete our roaming story. Q3 is focused on release 18 feature and better operational tools. CLR improvements might not sound exciting, but they are important for people actually running this system. Q4 is when we tackle UPF performance optimization. That's going to be a significant effort, but it's necessary to make Open5Gs competitive for high throughput scenario. Thank you for your attention. Open5Gs has become a long way from what hobby project I started in 2017. Having a community of developer and user who actually care about getting 5G technology right has made all the difference. Whether you are doing research, building prototype, or considering production deployments, I hope Open5Gs can be useful foundation for your work. Yeah.
Suchan, thank you very much. Yes, congratulations for all your work and achievements. I believe there are questions on the chat. We are quite okay in time, and I know you will be leaving soon. And thank you for joining, even if it's
Yeah, I'm sorry, but I try to stay as possible.
no problem. Let me then,
Yeah.
for 5 minutes, open the floor for questions because we know you are leaving. You won't be able to join later. Are there questions for Suchan that we want to take online? If so, please raise your hand. I believe there is a react button somewhere on your on your dashboard from Zoom. I see one. Mbarak, go ahead.
Hello, everyone. Thank you for the presentation. Very informative. I think we are almost two asking for the same question. It was how to be able to test roaming with Open5JS on the lab. Can we run to Open5JS and how we can implement this and try testing roaming? If Roberto wants to complete the question, he's welcome.
Yeah, Basil was asking the same. How do we use the OpenFIGS? And I mean, to test it is not necessarily as to choose OpenFIGS, but which other implementation of code did you use for testing this roaming? I mean, OpenFIGS with another technology and so on. Is there any manual or somewhere where we can start with?
So from the OpenPipes document, there is some very simple setup example for the roaming. But this is not good for you. There are just some simulation environment. So I cannot provide the real example, real practical solution to set up the roaming. But if someone can help this, I'm welcome to publishing this document. Yeah.
So let's do one thing. So what I will do is to take all the questions as they are in the chat. So we are going to store the questions and the answers, and then perhaps I'll try to figure out how we can put these questions like visible somewhere, so that there can be a follow-up, right? So if people even have more questions, that can be fine-tuned. I'll think about it, where to put this. Perhaps in GitHub, we open some issues and so on. Ademo, I have a question. I mean, I don't see more hands. I have a question, Suchan. Do you have a map? I mean, I posted it on the chat. Do you have a map of the coverage of Open5GS when it comes to 5G core network functions? For instance, we were looking for instance, a PCF implementation. I would say release 17 compatible, in order to drive some like service operations related to quality of service policies and so on. Do you have a map or somewhere like, okay, we implement this and this is compatible, this function is compatible with, or it's up to date until this release and so on? Do you have such kind of map somewhere in the website, or is this something you have somewhere?
Oh, what is the meaning of map? So
well, a map. I mean, I don't know. A list of, okay, PCF. For instance, imagine Open5GS has a PCF implementation and it covers up to release, I don't know, 17, and that's an example. Is this information
17?
Somewhere?
I cannot understand exactly your question. Can you write some chat? I'll see the written. Can you provide some written?
Yes.
Provide chat. Yeah, your question. Is it right? This question.
Yes, it's in the chat. Look for it, and you can answer. You can answer in the chat now before you leave.
Okay. Yeah.
Okay.
Let me answer.
Perfect. Find it on the chat. All right. So
yeah. Okay.
We had 5 minutes. Sukchan, feel free to leave and actually go for dinner or sleep. And thank you very much for joining. We move on to the next speaker on 5G core implementation. It's free 5GC, and it's Professor Chen again. So, Professor Chen, the floor is yours.
Okay. Yes. Yeah. According to this, your email, we actually put together some of free 5GC specification and how to contribute it. And So I'm going to. So for free 5G specification, it's release 15, 6, 17. We are standalone supported. We are service-based interface supported. We support N1 and 2 and 3 and 4 and 6 and 9 interface. So network function, basically we uh, outside of AMF, SMA, UPF, we actually has a charging function, which can do online and offline charging. And web console is act as a billing domain. It's a flow-based charging on PDU session. And as well as we have uh, network slicing selection function. And we also have we call non-trusted non-3GP PB interworking function. And since we don't have device to test it, so we actually implement N3IW UE non-3GPP interworking user equivalent to test this network function. And we also had TNGF, trusted non-CGPP gateway function. And yeah, at the same time, we have a trusted non-CGPP gateway function user equivalent as a software emulator. And we have NEF, this some network function we have. And support feature registration, yeah, authentication, which has a 5G AKA, EAP AKA prime, and now security. Yeah, I think that's feature which has been you can find on the website. And the charging, the so it's flow base. We support QS, but in the control plane only. So data plane, we are working on it. And we had slicing, and we have multiple UPF and URCL, OAuth2 on the service-based interface and traffic inference. And how to contribute it? Basically, yeah, you raise the GitHub issue. I can create an issue on a free 5GC repo directly, bug report, feature request, and then our students will take it and try to solve the problem as soon as possible. And you can create a page, you can do the pull request. So source code is in the GitHub, and you also can become a contributor. And so if you add it to the you will be added to the contributor list once your pull request is accepted. And so at the same time, you can go through the design document, which has software architecture, dedicated issue and solution, some domain knowledgeable 5GC development. And we also have set of free 5G labs. Actually, it's a hand-on lab of 5G free 5GC. So a set of lab to let you familiar with free 5GC. And we have development community like free 5G forums, GitHub issue. And potential area collaboration include like yeah, we to build a map to check which project is offering what. And it's yeah, that's so and some test tool, test method. All project has their own test tool and test method. So basically, we should have yeah, cooperate in that area and system integration with some open source RAN project, and also try to enhance our the labs, hand-on labs, so people can be familiar with 5G core. And we also hold our first free 5G World Forums in conjunction with ACM CCS 2025. So welcome to submit a paper. And since we are like universities, right? We are training students. We are doing the research. So we have students working on very topic like a QoS using P4 as data plane, and so we can reach 3.2 terabit per second. And we did some time sensitive networks, 16, 17. And student also working on 18 deterministic networking. And we had asset traffic steering, switching, splitting for TCP and UDP. And now students working on the 5G LAN in the data plane. So we have multicast using 5G LAN. And we also have voice over new radio. We have a 5G network function digital twin. And then we current one, 3 students are working on the network data analytic function for variety of application. And then we also have a new radio dual connectivity will be released soon for people who need dual connectivity for a large throughput. So yeah, if I have time, I can go more detail, but I'm not sure if there's any question now or...
Well, thank you very much for all this. Let's get questions also, like 5 minutes for questions. I think we can get time back from the end. Are there questions?
Because okay. Any question?
Give me a second. I'll open. Yes, I see a question from Rama Latar. Go ahead, please.
Yeah, I think you already answered my question. I asked about the NWDAF, if you will be implementing it. Do you have a timeline, or like when do you think that would be published or ready?
Okay. Yeah, we can show you what we did. Actually, it's finished, but yeah, NWDF, what do you talk about, right?
Yeah, exactly, the NWDAF.
Okay. We haven't finished it, but students defense July, and so basically we haven't really cleaned the code yet. But basically, for example, this work is try to apply one of DAF into like a balance the CPU loading and memory. So with the data, then we can actually dynamic adjust the charging UR threshold, so can basically let the CPU loading can be like a can be this is for charging function. This is for SMF. So with dynamic, it's blue one. Okay, without dynamic, kind of just then according to the NWDF, then you could be have CPU loading which much higher, and so affect your performance. So yeah, that's something we have done. We're still using this for like malicious user detection, for like edge device selection, edge service selection. So we still using NWDF for multiple research topics. So, but
Right.
I'm not sure when we are ready to release it, because
Okay.
still working on it, and we still want to be solid tested. Okay.
Yeah, makes sense. Okay, thank you.
Very well. One more question, Mbarak.
Thank you, Jordi. This is a question for everyone, I believe, here that are proposing some open source solutions. I'm wondering how you involve universities to collaborate on all those open source platforms. First, how we can train them for them to be skills in house to collaborate and contribute to these platforms or solutions. For
Yes,
and
now
is
it's
there a
under.
limit? Is there any limitation in countries?
No,
Is it restricted to
there's no
Europe or
limitation now. No, this is not under the Linux Foundation. So yeah, Linux Foundation actually announced this in Europe in September 2024. In the Europe open source kind of consortium or something, they announced it. So now our project is under Linux Foundation. So there should be just international available for everybody.
can you please write it on the chat so I can review it later on? I'm thinking about African countries that are getting more and more skilled students, and we don't hear about them that much. And perhaps we can train them and get them involved and getting more contributions.
Okay.
Thank you.
Very well.
Welcome.
I'll write a question, actually, just to capture this. I'll write a question for all. Are your projects open to academia, let's say, worldwide? I'll put the question on the chat and then
Thank
everybody
you.
can answer. And there
And
will
most important, how we can involve them with the first step, training them, and then mm, mm, give them the
Yeah,
opportunity to contribute.
as I say that basically we have some lab, right? So this just you can familiar with Free5GC through the Hanlong lab, and we have design document and the GitHub, and so we have forum, we have so you can ask any question, and we try to answer as soon as possible. So yeah, I think that's available in anywhere. So basically, yeah, we welcome people to involve, and yeah, so
fully open.
yeah, fully open is Apache 2.0, and so you can do whatever you want. And so you need to even contribute back. So yeah, so basically it's very free. So yeah,
Excellent.
so I
Thank
don't
you.
see. Yeah.
Thank you.
Very well, excellent. So I believe there will be follow-up. I mean, this workshop is just a one shot, right? And we don't have like infinite time to do this. But I believe a follow-up, for instance, on what Professor Chen suggested of a map of who is doing what, right? What is interoperable with other projects? How can we build demos together or reusing components from here and there? I think that's something at least I believe of interest for FiGMAC for sure. Very well, so let's move on. We are going to jump now to OpenAirInterface, also on the 5G core, and I would like to welcome Tien Thin to present on behalf of OpenAirInterface. So I believe
Thanks, Ogdi. Can you hear me?
I can hear you.
Okay, so let me share my screen. Okay. Can you see my screen now?
Yes, it came. Please go ahead. Thank you.
Okay. So good morning, good afternoon. My name is Tien Thị Nguyen. I'm a principal researcher engineer at Aerocom, which is a founding member of OAI, as mentioned earlier by Robert. And I'm also a technical lead of the OAI Core Network project. So let me give a brief introduction to the implementation, current status, and the roadmap of the project. The OAI Core Network project is one of four main projects under OSI umbrella together with RAN, CI/CD, OAM, as mentioned earlier again by Robert. You can find here the link for the project website and the code. Currently, the code base is relatively big, but Unfortunately, there are a few main contributors, so many from OAI Aerocom team. So you are very welcome to contribute to the OAI code base. For the current status of the OAI core network, you can see here this figure highlight the high-level overview of the core network in terms of network component and the interfaces. For now, we already have the implementation of 11 network functions, including AMF, SMF, UPF, PCF, just name a few. Two network functions are under development, NEF and UDSF. We also plan to add some more network function, for example, SCP and application function. For the feature and procedure supported by the OAI core network, OAI core network provide a very stable version for supporting basic procedure and feature to provide a cloud native deployment with either Docker Compose or Helm chart. OAI core network also provides several advanced features, as you can see in the list. I just want to highlight some important feature. For example, OAI core network can provide several event exposure services to allow a third-party application to collect the UE static information and then probably configure 5G core network on the fly, of course, according to the connected information. It's also important to mention that we also have NWDAF, which collect data from different network functions to perform analytics on this data. So to provide the insight into the performance and health of the network. I would say that NWDAP together with the event exposure services could serve as a very good foundation for AI and machine learning based decision for automatic deploying, managing, and optimizing the mobile network. Another important feature in network slicing, OAI core network support network slicing per UE and per PDU section. And recently, we also added NMF to support location services. And finally, OAI core network also support QoS for both control and data plane. We understand that flexibility is the key driver for 5G adoption. So OAI core network provide different flavors for both control and data planes, aiming at different 5G application and use cases. So at the end of the day, the end user can pick the most appropriate option based on their need. For example, for the user plane option, the first one is UPF simple switch, which is easy to deploy and manage with sufficient performance for most of the use cases. So suitable for example, functional testing and validation. On the other hand, UPF based on eBPF, XDP, a soft UPF, providing a very promising performance, basically can fulfill the need of the different scenario for 5G and beyond. So we talk about the performance evaluation in the next couple of slides. And to guarantee the quality of the code, all the implemented procedures have been validated with a different scenario and pipeline in our CI and CD framework. For the functional validation, we validated our core network with OAI GNodeB, with both OAI UE and COS UE. So that OAI can provide an end-to-end solution for 5G standalone for RAN, core, and UE. Originally, we also validated OAI core network with several commercial GNodeB with COS UE and with some open source RAN simulator as well. For the performance evaluation with simple switch, we can achieve around 800 megabit per second uplink and downlink with Docker and 1 gigabit per second with a parameter. For the eBPF XDP, let's say we are proud to announce a significant milestone testing with T-Rex, a traffic generator OAI UPF, eBPF, XDP can achieve nearly 100 gigabit per second. This achievement highlight OAI commitment to pushing the boundary of the open source telecom and delivering cutting-edge performance. For the roadmap, as the number of the network function and supported feature increase, maintaining and improving the code quality become one of the most important tasks of the OAI core network project. We keep improving the code quality and to make it more stable, more robust by simplifying the code base and refactoring the code regularly. And step by step introducing unit tests for the main components and libraries. We understand that the optimization and simplification of the OAI core code base is particularly important in the context of 5G, beyond 5G and 6G. For example, to add a new procedure, feature, network function to support a new 6G RAN and use cases. We can also actively, actively provide the fixes for the bug reported by the end user to make OAI core network more stable and work with a wider range of code series. And for the new feature and component, currently we are working on some important topics, as you can see in the list here. Some of them already available in the develop branch. Some of them are ongoing. In more detail, we are very proud to be one of the first core network to support Ethernet type PDU section, which is important topic to support TSNs. Traffic steering for service function chaining and frame routing are also available and soon to be officially released. We are also working to update NAS and GAP, PFCP, and SBA interfaces to release 17 and then release 18 later on. Another important topic is that we are working on is to perform the interoperability test to provide the fixes to make at least AMF, SMF, and UPF from OAI to work with the other component from the other core network solution, including 5G, Open 5GS and 5GCs. And that we give the end user the possibility to pick different components from different open source core network to build their own core network. Besides, we're also working on a dashboard to configure the core network function and checking the UE and network function information. Then there are also the other important topic that you can see, particularly time sensitive networking. Time sensitive networking and state list a network function for the AMF and SMF. So let's say that we are committed to providing a robust, performant, and full 3GPP compliant 5G core with a rich feature set. So with that, I conclude my presentation and thank you for your attention, and I'm very happy to answer the question.
Tiantin, very well. Thank you very much. A lot of information. I believe we will need to revisit the video afterwards. Let's take questions online. Let's allocate 5 minutes for questions. I believe there's one on the chat that can be answered perhaps online.
Let me open the
So is any particular reason for not having SEPP in the roadmap?
Because for the moment we focus on the non-roaming scenario, and then later on we try to, because you see that the list of the roadmap is quite long, and then we are relatively small group, and then you are welcome to contribute. So if you have the project for SAP implementation, we are very happy to collaborate with you to implement this, and then we can support a roaming scenario as well.
Very well. Hope that answers the question. There's another one from Andrew. Is there documentation about the 3 UPF flavors? I don't know, Andrew, if you want to say anything, like to complement. If not, the question is there.
We have a paper, but it's not published yet. So we try to write a documentation in our website, and then soon we publish this.
Very well.
Yeah.
Are there more questions? I just have a comment from our side. So I believe what you mentioned about the interoperability between OpenInterface, Open5GS, and Free5GC, I think that's something I would say of high interest because some of our developers starting, let's say, because of their experience working with Open5GS. However, we were looking at, I mean, we were looking at other platforms and trying to understand, like, that's why trying to understand the roadmaps of what's available, complying with which release, because there are some functionalities we want to use, right? So for instance, from one project, we don't have access to some network functions that may be in another project. So all these kind of interoperability, I think it's really important. And I believe we will be following up with you on this, at least from 5G Max side. And then I have another question in particular with time-sensitive networking. This is something we've been looking at. However, we were failing to find like NWTT and DSTT implementations. Is this something you are working on when it comes to TSN?
Actually, we have the project working with the different partners across Europe, and so we are committed to provide the support for the core network for the time-sensitive networking, but we don't provide all the functionality. Some of them we come from OEI, and the other we come from our partner. So you can see here that the Ethernet type PDU section support is one of the features that we be used by time-sensitive networking. So you can see, and then the other we coming, for example, application function for DSN. That's you can see in the figure on the right. You see the application function for the
Yes,
for the
yes, and
DSN.
again.
Yeah.
Yes.
So there are a lot of how to say topic related to the TSN, and we are working to how to say implement not all of them, but work with the help of our partner. We can try to support to provide an end-to-end support for the TSN.
Mm-hmm. Very well. No, I fully understand. I mean, sometimes I get the feeling that we want to have things ready, right? But the actual work needed to implement them, it's substantial. So it's not something that is like, oh, it's not just a wish list. It's actually getting it done. So I fully understand. Very well. So let's continue getting questions, in particular for the OpenAirInterface 5G core network, and perhaps for all the presentations related to the core network, but we need to move on to the RAN.
Let me stop staring.
Very well.
Okay.
Thank you for the presentation. And as I said, there's plenty of information. I believe we need to get the slides, revisit the videos afterwards, and so on, because I mean, this kind of one shot, it's been very, very useful. Let's move to the RAN. So I would like to again invite Brendan from srsRAN to introduce a little bit the topics they are implementing at the moment for srsRAN when it comes to the NG-RAN, I suspect. So Brendan, if you are able to share screen, the floor is yours again.
Okay, great. Just checking, you can see that? You can see my screen?
Yes, all good.
Perfect. Okay, great. So yeah, I'll just take you through a little bit about srsRAN project, a bit more of a technical overview here, focusing more on the open source project rather than us as a company. So what is srsRAN project? I guess this is the main question that we should address. So it's like I said before, it's a 5G ORAN CUD solution. It's developed fully in-house by us here at SRS. That means it's got no kind of strict dependencies. It's got very, very minimal libraries that are required to build it, and everything is coming from us, right? It's fully aligned with 3GPP release 17, and like I said before, it's available under AGPL v3. So the CUDU is designed with these 6 core tenets in mind, and these tenets are supposed to kind of guide the design process, and now as we have a more mature product, it's supposed to kind of guide how we maintain it and add new features on top. So this is supposed to help both the open source stack and our commercial customers. So we try to make the code complete. By that we mean it's both completely from us and complete in terms of features. It's portable, so it should be scalable and portable across multiple architectures and various sizes and resources of compute platform. It should be performant. Again, depending on what platform you're running it on, you should be able to get it to perform at the best level. It should be open. By this we mean open RAN, open source, open interfaces, as much as it can be. It should be flexible, both in terms of the use cases it can support and obviously the hardware it can run on, and then interoperable. So whether that means interoperable with taking our CU with the different DU, our DU with the different CU, various cores, RUs, RICs, SMOs, all in line with the kind of the ORAN standards. So just one point to note here, I guess, and it's kind of to address a question or a statement that we hear a little bit more often than we'd like. So srsRAN project is not an emulator. It's not a simulation environment. It is a commercial grade deployment ready solution that is available as an open source project. And you can see here, so this is our software architecture and the diagram on the right. And you can see we have support for all of the ORAN interfaces and also support for, well, basically all of the ORAN splits, but we focus on split 7.2 and split 8. So we enable split 7.2 over our own custom open fronthaul interface. And with split 8, that's more designed for, I guess, working in more research environments where you're using something like a USRP. Okay, so then a little bit about the development timeline. So a lot of you would probably remember srsRAN, or well, srsLTE as it originally was, and then srsRAN 4G. So in about 2021, we started development on what was to become srsRAN project. So this was basically learning from everything we had done for srsLTE and srsRAN 4G, and then building a completely new code base. So srsRAN project was built from the ground up, basically from zero to what it is now. It's a completely different code architecture, software architecture. It's a completely different approach to how we develop the product. So for about a year and a half, we worked pretty much in silence. And then in early 2023, we had the initial release of srsRAN project. And then following our usual release cycle of kind of twice yearly tagged releases, we then had our first tagged release in May of 23, bringing us all the way up to now with, I believe it'll be out actually either at the end of this week or the start of next week, 25.5, so our latest publicly tagged release. Between all of these releases, and I'll touch on the release cycle a little bit more in a second, but we do have kind of rolling releases, so we have shorter, or not shorter, but rather smaller updates every couple of weeks, kind of addressing small bugs, maybe enhancing certain features or adding smaller, newer features. The tagged releases are then kept for adding larger features. So our current features as of what will be 25.5, so we have full FDD and TDD support for all FR1 bands. We have all bandwidths. So for example, 100 megahertz CDD or 50 megahertz FDD. We have support for 15 and 30 kilohertz subcarrier spacing, all physical channels. We have highly optimized LDPC and polar encoders and decoders for both ARM and x86. So I don't believe I mentioned that, but it is worth noting that srsRAN project is, and srsRANinterface for that matter, is designed to be deployed on any system architecture. So x86, ARM, and then plays well with all families of processor. So we also have support for all RRC procedures, all MAC procedures. Like I said, split 7.2 and split 8. 56 or 256 QAM in both the uplink and downlink, 4x4 MIMO, slicing, NTN Geo, and the CU-DU split. We also support obviously the E2 interface, and this is in fact tested with FlexRIC from Eurocom and the ONS-CRIC. In terms of 5G cores that we support, we typically tend to use Open5GS, but it's also been tested by our community with Free 5GC and also various other commercial and open source cores. In terms of our roadmap, so we plan to add the CU, CP, and UP separation, FR2, higher order MIMO, and then further interoperability testings with further RUs, RICs, and cores that become available. So a little bit then about the development of srsRAN. So like I said, we're 27 full-time employees. We're at about 20 engineers, 20 to 24 engineers focused on development and testing full-time. So we have three main teams. We have the development team, the testing team, and the integration team. These are constantly working in tandem to basically create new features, test them, integrate new hardware as they come online, basically ensuring that the code that we publish and make available to the public is to the best possible quality in terms of stability, performance, and features. So srsRAN is written in C++. Anybody that has, I guess, downloaded the code and used it will know that, C++ 14. Anyone that hasn't, you too know that. And the code is written to a very, very strict set of guidelines. Again, I'll touch on that a little bit more towards the end when I talk about contributions. But this just basically means that the code is all written to these strict guidelines so that it's very easy to understand. It's very well commented. The mechanics that we use are well documented in our documentation. And then it just makes it easier for people to basically understand the code, understand how we got to our implementation of the standards, basically. In terms of the languages that we use, so like I said, C++ is the main language for srsRAN. We use CMake for the build environment. We use MATLAB for testing and prototyping. We use Python for our CI/CD and our emulation, and then we use Bash for various scripting. The release cycle then, so like I said, we do rolling updates roughly every 2 weeks. This kind of depends. It's not a very strict kind of cadence, but it tends to be every 2 to 4 weeks. There's a smaller release, untagged release, and then we have our tagged releases twice a year. So each release candidate must go through very, very strict testing and conformance. Like I said, kind of adhering to these rules that we have, that everything that we push out is tested rigorously so that nothing goes to the public broken. And our documentation then, which is a huge side of the user experience for us, it's updated after each release and on a more ad hoc basis than the code. So as part of my role here at SRS, I'm actually responsible for the documentation. And so I try to make sure that this is updated basically in line with every tagged release. And then as we hear back feedback from users, or we notice things ourselves within our testing, we tend to upgrade and update the documentation as it's needed. In terms of contributing to srsRAN project then, so anybody can contribute to srsRAN project by issuing a pull request from the GitHub page. Like I said, all code needs to adhere to the code style guide that we have and the testing policy. These are all outlined in our documentation. It's a very extensive document. It goes through, the types of mechanics we use within C++, how to use them, how not to use them, what to use, and what not to use. Users also, our contributors rather, also need to agree to a CLA. So, we do say that srsRAN project is always open to contributions. The guidelines for this are quite strict, so there's not, a vast amount of community contributions like there might be in other projects. But the reason for this is that because it is at its core the basis for our commercial product, we try to keep the code to the highest level possible. And that's not to say that we don't take contributions. Of course we do, and there have been many over the years. But, anything that does come in has to go through these rigorous tests. So then some important resources for our users. So obviously we have the documentation that's available at docs.srsran.com. And like I said, I'm responsible for this mainly. So this is constantly updated. We have general guides, the user manual, developers guides. We have a knowledge base with some information about ORAN. And then, we've a long list of tutorials that's constantly growing, outlining various use cases, how to do certain things with the code. For instance, using FlexRIC, using ORUs, an NTN use case, the list goes on. We also have GitHub discussions, which we use quite extensively for basically user support for the community. So people can go here to have some questions. Maybe they need some help understanding something, or they want to report, that they tested a new COTS UE with the code and it works, or they've done something interesting that they want to tell the community about. So it's essentially, I like to describe it like a Reddit thread for all things srsRAN projects. So this is very, very active. It's actually at the point now where we, as SRS, we don't have to engage with it as much as we did in the past. It's a lot of users helping each other out, which is really, really, really great to see. That this open source community is going from strength to strength. Yes, and then some more important resources. So we, and this touches on a question that somebody had a while ago about university involvement. So over on our website, we highlight lots of news and success stories from within the community. So these might be things we're doing with the open source project in terms of involvement in European projects, like you see here in the screenshot, blogs from users, demos from users, the online resources that people are sharing centered around srsRAN. And we also highlight research papers. So these are coming from mainly, universities, highlighting any research that is basically clearly using srsRAN to do their research. This ranges from, master's thesis to PhD thesis to published papers in various journals. One thing I do want to kind of go back on here a second, actually, is about our, I'm going to skip back, about our development timeline, our development cycle, and how we decide what features go into the code. So because we, as I explained before, we use this open core model insofar as srsRAN project is the basis for our enterprise product. A lot of the features now, as we've kind of addressed a lot of the 3GPP, the main 3GPP features, a lot of the additional features are driven by kind of two things. So either commercial customers that are looking for a specific feature, or the research projects that we're involved in, the SNSJU projects, Horizon projects, etc. The features that are required by those projects are also driving our roadmap and our feature list. Okay, so this leads on nicely to collaborating with us as a company, collaborating with the code base. So we most commonly engage in, like I said, publicly funded projects and commercial engagements. We also keep a close eye on the open source and academic communities. So this is done via LinkedIn, X, discussions, and the published papers that I mentioned. And, we're always happy to hear from users either directly or indirectly about what they're doing. And you can keep up with that and let us know about anything you're doing from within our social channels. So one last thing I want to mention before I finish up is the upcoming event that we have. So every year for the last couple of years, we have done a project workshop in collaboration with CCI at Virginia Tech, usually in the fall. So last year it was October. This year it's going to be in November on the 11th and 12th at the VT Research Center in Arlington in collaboration with CCI, like I said. So registration for this is open and live. But we also have an open call for demos and speakers from within the community. So this could be anybody from, a research group or a team within a university, or just, general hobbyist users that want to share what they're doing with the srsRAN project. And so this is a great event for that. It's really cool. It's quite a large mix of kind of R&D and academia, but also people from industry, government, kind of all across the spectrum of srsRAN users. So that's it. Again, I'd just like to say thanks to you all for listening, and thanks to the guys at 5G Mag for having us. If anybody wants to reach out to me directly after this webinar, my details are on the screen. So my email is brendan@srs.io, but you can always reach out to us at info@srs.io or on LinkedIn or on GitHub. So that's it. I guess, I don't know, do we have time for questions now, or do we want to do them at the end?
I would actually offer now one or two questions, and at the end we don't need the time. So please, are there questions for srsRAN? I don't see coming. I have one actually. I mean, we have, as you know, in 5G Mag, there's a community also with interest on NTN. You mentioned you are starting to provide support, or you plan to provide support for NTN Geo. Can you elaborate a bit? I mean, is it for kind of messaging services? What kind of services, or what's the motivation behind the development of NTN Geo?
So I guess just to kind of more broadly address the NTN support within srsRAN project. So the srsRAN project, the open source code base, has support for Geo. srsRAN NTN 5G, our commercial NTN offering, has support for Geo and MEO.
Right.
So that there's a slight difference there. Yeah, in terms of the support, I guess it's and I will say NTN is not my area of expertise, but the initial support, is enough for a lot of research applications to do what they need to do in terms of the geostationary features that are supported. I don't know if that answers your question. I guess that was a very hand-wavy answer. I apologize.
No, it's all good, Brendan. And as I said, we can follow up later.
Yes.
There's a lot of questions. One more question. Ugur, please go ahead.
Yes, Brendan, for the OpenRU, the radio unit, I suppose you don't have it as SRS. Are you imposing any particular ORU to your customers? Are you suggesting any particular one?
Yeah, great question. No, so we don't provide an RU. I mean, we're a purely software provider of the CU and DU, but no, we support all ORUs. So anything that's standards compliant, we support. We've currently integrated with, I think, over 30 RUs, and basically after a while, everybody does have their own flavor of the standard, but through the kind of the extensive integration, we have extended our configuration file in such a way that the Genode B can be configured to support, I would say, 99% of ORUs, unless somebody out there has done something that's wildly outside the standard, then we support them. For example, Lighton, Benetel, VDN, MTI, these would be some of the main ones that we see people using. But no, we support all ORUs.
That's interesting. Thank you.
Yeah, no problem. Thank you.
Very well. Brendan, thank you very much. We continue a little bit offline. We need to move on. I'd like to welcome now, thank you, Jaroslava from OpenAirInterface on the RAN implementation. So, Jaroslava, if you are online, please share your screen. The floor is yours.
Yes, hello everyone.
Hello.
I will share my screen now. So can you see the presentation?
Yes, it's here.
Okay, perfect. So my name is Jaroslava Fidlerova, and I'm happy to be here today presenting the OpenAirInterface RAN project. I've been working at OAI team for over 2 years now as a development and testing engineer, and a significant part of my current responsibilities is also focused on topics related to CI and testing. So today I will present an overview of our 5G radio access network, covering the core feature set, performance indicators, deployment examples, and also our roadmap for upcoming enhancements. So let me start with the overall feature set currently implemented in the OpenAirInterface RAN. There are two main deployment types that we support today. The first is the OAI Genode B, which consists of a centralized and distributed unit, and the second is the OAI user equipment, OAI UI. Both of these components have been validated for interoperability with commercial equipment. Taking a closer look at the Genode B side, we currently support FR1 and experimentally also FR2 frequency ranges with bandwidth from 10 to 100 megahertz and even 200 megahertz in FR2 setups. In terms of modulation and MIMO, we support 256 QAM modulation and up to 4 downlink layers and 2 layers in uplink. We achieved downlink throughputs of up to 1.3 gigabits per second, with latency down to 5 milliseconds round trip time, depending on the application and TDD configuration. From a functional perspective, the OAI G-Node B can support up to 16 UEs connected in its default configuration. However, with minor software modifications, we are able to extend up to 64 UEs. Our RAN platform supports multiple interfaces compliant with standards defined by 3GPP, ORAN, and Small Cell Forum, allowing for integration with third-party components. We also support multiple DUs and CUCPs connected to a single CUCP. Another important feature is E2 agent on the G-Node B through FlexRig and support for O1 interface through O1 adapter. Additionally, the G-Node B supports both inline and loop-side acceleration using NVIDIA ARC platform and AMD T2 telco accelerator card. We are also working on integration of the Intel's vRAN Boost integrated accelerator. I will mention that later. Finally, the OAI includes basic support for RedCap UEs as well as support for non-terrestrial networks, specifically for LEO and GEO satellites. A complete feature set you can find on our repository. So let's take a closer look at the OAI G-Node B performance. In the following tables, you can see downlink and uplink throughput, which we were able to measure depending on the number of layers and bandwidth configurations. Looking at the maximums in downlink using 100 megahertz channel bandwidth with 30 kilohertz subcarrier spacing and 4x4 MIMO configuration, we measured throughput up to 1.3 gigabits per second. And for uplink in 60 megahertz bandwidth setup with two-layer MIMO, we have achieved rates of 175 megabits per second. These measurements were carried out in collaboration with our partner company, AllBeSmart, using USRP N310 and fronthaul 7.2 compliant radio units, along with the commercial user equipment. Now I would like to focus on the interfaces which we have integrated in the OAI RAN. For management and control, we support both O1 interface for operation and maintenance and E2 interface for near real-time rig applications. CUUP is communicating with the CUCP via the E1 interface, and we support multiple CU user planes per control plane. The CU connects to the DU using the F1 interface, which supports multiple DUs connected to a single CU, which is important for mobility support and F1-based handover. Between the MEC and PHY, we integrated support for the Small Cell Forum's 5G FAP interface, and we have achieved interoperability with NVIDIA Aerial Research Cloud using this interface. Regarding the fronthaul, we support the classical split 8 option with the UHD and USRP as the radio. In split 8, we also support the eCPRI in cooperation with the AW2S radio unit. And for the 7.2 split, we use a libx run from ORAN software community. And we've successfully integrated user control and synchronization planes and demonstrated interoperability with multiple third-party RUs such as Benatel, Lighton, BBD, and Metanoia. With Benatel, we also support the M-Plane interface for RE management. More details about the M-Plane will be provided in the next presentation about the OEM. Now I would like to present you two sample deployments with OpenAirInterface. So the first deployment represents an end-to-end setup integrating the ORAN 7.2 interface and the AMD T2 accelerator card for LDPC processing. I will focus mainly on the setup with Benatel, where we have also support for the M-Plane. So going from the bottom to the top, we connect the OAI-DU low to ORU using M-Plane, retrieve its capabilities such as RF capabilities, compression methods and interfaces, subscribe to all notifications, and configure the control and user planes. We leverage the OpenFront library from the ORAN software community here. Optionally, we can use LDPC decoding and encoding offload to AMD T2 telco hardware accelerator. Then the OAI-DU interfaces with the OAI-DU high with the small cell forums and FAPI split, which is encapsulating the FAPI messages transmitted over UDP. The OAI-DU high is further connected to OAI-CU-CP via the F1C interface and exchanges user plane traffic via the F1U interface with the OAI-CU-UP. This setup was deployed on two separate hosts as shown in the picture, with the DU low running as a service on one host and DU high, CU, and core network deployment running in Docker on another host machine. We also test with similar deployments on OpenShift cluster, which is a container platform provided by Red Hat, built on top of Kubernetes. In this setup, we conducted tests with 100 megahertz bandwidth and 30 kilohertz subcore spacing, and we reached up to 1.1 gigabit per second with 4 layers in downlink. As UE, we tested here with the commercial Quectel module, and also we did some tests with Samsung S23. So another sample deployment shows the integration of the OAI with the NVIDIA Aerial Research Cloud, which is a GPU-based layer 1 inline accelerator. This accelerator consists of the network card and the GPU, and basically the entire layer 1 is processed on the NVIDIA GPU. The physical layer is interfacing with OAI-DU via the small cell forum 5G FAP interface. And here we combine the DU high and CU in the single executable, and in this setup we can reach a throughput up to 1 gigabit per second with 4 layers in downlink MIMO, and around 50 megabits per second in uplink. There is also an ongoing work on integration of OAI L1 with Redis L2. Here we have prepared a slide about the 5G NTN support. As I mentioned earlier, OAI has initial support for NTN communication for GEO satellites and LEO satellites. NTN GEO was developed as part of the 5G GOA project of the European Space Agency, and it's supported on both the GNode B and the UE side. Support for long propagation delay was added to our RS simulator, which allows for testing the NTN scenarios in software. NTN LEO was developed as part of the 5G LEO project. Some GNode B and UE features are already merged, such as support for 32 HARC processes, channel simulation, or continuous frequency offset compensation, and other features, for example, continuous SIP19 updates on the UI are currently under integration. For both NT and LEO and GEO, we have integrated tests into our CI framework using the RF simulator. Main contributor of these NT and related features to the OAI is Fraunhofer IIS. So I'll quickly go through the roadmap for the first part of this year. So we have integrated multi-UI bandwidth part handling and two-step random access procedures, which is basically a faster form of the random access procedure. I was already talking about the NT and LEO and GEO support and support of the NR RedCap. In the sample deployment I presented before, we have successfully validated integration of mPlane and NFAP interface. Looking into the Q2, there is an ongoing work and testing of Intel's VRAN Boost integrated leukocyte accelerator, which allows for more efficient processing of physical layer functions such as LDPC encoding and decoding. And to support general UI mobility, we are going to finalize integration of N2 handover procedures. Now I'm going to introduce you the OAI roadmap for the second part of 2025. So we are planning to work on the quality of service aware scheduler, which allows us to ensure guaranteed maximum and minimum bit rates based on the quality of service requirements. We are planning to integrate support for 5G slicing. There is also an ongoing work on implementation of beamforming procedures for both frequency ranges to be able to switch between multiple beams. And to further optimize physical layer performance, we plan to integrate GPU-based LDPC accelerator. There are several features planned for the final quarter of this year, such as massive MIMO support, NR positioning protocol support. We currently have a basic sidelink functionality implemented on the UI side. It's also tested in our CI. But as a next step, we would like to implement also the sidelink relay. And another step towards the UI mobility is integration of XN-based handover. Finally, we plan to integrate support for Category B devices of the O-RAN front-haul interface 7.2. Which expands the interoperability with the wider range of commercial ORUs, and especially for the massive MIMO deployments. So to conclude this presentation, I would like to share some practical guidelines on how you can get started with the OpenAirInterface and how to stay connected with our community and ongoing developments. The place to begin is, the best place to begin is our official GitLab repository, which serves as the central hub for all our software documentation and development tools. There you can find tutorials from basic setups to advanced features such as front-haul hardware acceleration or CI integration. For community support and ongoing collaboration, we invite our partners to our Slack workspace, and in addition, we maintain a public mailing list which provides another valuable channel for users to ask technical questions, report issues, and receive input not only from the OEI team, but also from the broader community of OEI users. I would like to also highlight that several companies offer OEI-based ready-to-go setups and support, which makes OEI deployment even easier. Thank you very much for listening, and if you have any questions, you can ask now or in the chat. Thank you.
Thank you, Jaroslava. I think we move the questions to the chat as we are getting squeezed in time. And let's go for the next presentation. It's also from OpenInterface. Theodora Vladik on OAM. So please share your screen. Floor is yours.
Thank you so much. And hello, everybody. My name is Theodora Vladic. I work for OpenAirInterface 2.5 years now. At the moment, I'm the maintainer of the FlexRig, which I will detail in just a few seconds. And the same time, I'm the main person for one of the main people for the 7.2 interface, the integration specifically for the endplane. So the OEI, one of the groups, project groups within the OEI is OEM, Operations and Maintenance Group, which has as objective RAN monitoring, control, and management. The RAN monitoring and control is achieved via E2 and O1 interfaces that we both support, and the E2 interface and the O1 and M-plane interfaces for the management, although O1 can be used for the control as well. So the FlexRig is basically a repository that consists of the near real-time rig, which is compliant with the O-RAN specifications, the XAV framework, as well as the E2 agent emulators. It supports multiple versions of the E2AP protocol, version 1, 2, and 3. And as a list of supported service models, we do support two O-RAN defined, which are key performance metrics, various versions again, V2 and V3, and the RAN control service model as well. They both basically use the ASN1 encoding as per ORAN specifications, but at the same time, we have some custom service models that use just plain encoding into the byte array. On the layer 2, more specifically, max service model, RLC, PDCP, GTP, traffic control, and the slicing control. Those service models are designed as shared dynamic libraries, and they have to be loaded on both sides, the E2 agent and the near real-time rig. The general aspects of the FlexRig is that it is multi-vendor for the RAN as well. Of course, in OEI, we have E2 agent, as mentioned by Jaroslava. And the srsRAN, of course, supports FlexRig, which we already heard in the earlier presentations. On the other hand, we tested with the Keysight RAN simulator, as well as the NS O-RAN. This is basically a platform that hosts, that merged basically E2AP protocol with the NS3, which is a millimeter wave simulator for cellular networks. We do support multi-RADs, multi-radio access technologies for 5G. Multi-agent, basically meaning that we can have multiple agents connected to the same near real-time rig with no latency at all, very little. I mean, depends on the machine as well. Multi-XAV, basically we can run multi-XAVs at the same time that hosts different service models, and it can be written in different languages both compiled and scripting languages with the Swig wrapper. As you can see in the picture, the FlexRig itself contains the E2 agent emulators for eNodeB, SUCP, SUUP, ODU, as well as the monolithic gNodeB. It has the, of course, near real-time rig and the XF on top. And the O1 the O1 interface is being tested with the ONAP-based SMO, but we don't support for now the A1's interface, but we do have some work from the Orange Innovation Labs. Of course, it can be deployed on the bare metal, but as well as in the container-based deployment, Docker, Compose, and Helm charts as well. We do support for multiple operating systems for the Red Hat, Ubuntu, and Fedora, and the images are already available on the main FlexRig repository. Here you can basically see one of the use cases, purely OAI end-to-end with the OAI, where we basically leverage the quality of experience use case. So the main goal is that with the commercial UE, we started playing the online game, but at the same time, of course, the OAI DU exports the UE performance metrics via KPM service model towards the XApp via the E2 interface. But at the same time, we started the hyperf traffic, basically to just overload the resources, and then, well, online game becomes unresponsive. And then we basically realized that the OAI OCU has to create a new data radio bearer in order to parallelize those two needs. And it is basically achieved with the run control service model. Completely the same setup is also tested with the OSC near real-time rig, H release to be more specific. So we do have interoperability from the run perspective with different available rigs. Another topic is the O1 interface. We implemented through ONAP-based non-real-time rig, where so the O1 adapter is a separate repository, also available on the Eurocom GitLab. And the SMO basically monitors the OAI DU through SDNC. And what we have also achieved is on the high ODU load, we can generate some alarms through VES. What also we can do with O1 interface is not only to monitor the configuration, but also to change the configuration. For example, we successfully achieved with the OAI DU bandwidth change, well, more specifically with the USRPs on the fly, basically through the graphical user interface of the SMO. And the third part of the OAM project is the management plane. We do support, as mentioned by my colleague Yaroslava, the full CUSM front haul 7.2 interface. At the moment with the category A ORUs. And we tested the Benetel and both indoor and outdoor units and Metanoia. We successfully achieved the startup and configuration management. For example, center frequency, multiple different MIMO modes, bandwidth, etc. And the performance management is ongoing. However, on the other hand, with only COS, we do have support for VVDN, Foxconn, Lighton, ORUs. And as you can see here, this is basically the management plane interface between the OAI-DU and the ORU. So it can be a part of the hierarchical and hybrid modes as per M-plane specifications. So even though we did achieve with between the DU and ORU, we highly invite SMO vendors to expand the M-plane towards the SMO, whether hierarchical or hybrid mode. But we can find a use case where we can work together. So the idea basically of the M-plane on the front haul is that the DU only needs the additional parameter, which is RU IP address. Once the DU starts, it all connects to the ORUs via the netconf protocol, configures entirely the CU planes, and the ORU is ready to receive and send packets back to the ODU. Of course, this is all tested with different configuration, layer 1 configuration, as well as we do support multi-ORUs, multi-ORU implementation. So we would like to invite any SMO vendor who would like to work with us on the M-plane. And here are some links that are regarding these three topics: the FlexRIC, which is basically for the E2AP protocol, the O1 adapter, as well as the M-plane tutorial, which is now part of, as you can see, the 7.2 tutorial. But hopefully in the future can be expanded to broader ranges with the SMO. That would conclude my OEM presentation. Is there any more questions?
Thank you very much, Theodora. Let's take the questions on the chat. I actually posted one for you, and then we'll revisit your slides and the video afterwards. As I said, we are going to overrun, let's say, 5-10 minutes. I'm gonna proceed with the last presentation, which is actually coming from 5G Mac. Hope you can see the screen. So I would just like to give an idea of what we are doing in 5G Mac in terms of the software projects, and then also that would give us some link to, let's say, to other presentations and to the systems that have been presented today. So as I said, we are running the 5G Mac Reference Tools project, which is an open source development community where we get reference implementations of different systems, in particular developed within the framework of 3GPP, although you know that at least for the multimedia topics, there are different legs, right, that also interact with other SDOs like MPEG, IETF, issues related to XR, for instance, on tools from Kronos Group. I mean, there's a lot of derivations on the work, right? So for instance, just very quickly, we have reference implementations of the 5G media streaming architecture. All of this will be available in the slides later, no need to go through it now, but this is basically, so the specifications define application function, application server, and then the client components, and we are developing them so that, for instance, you can benefit from let's say advanced network features from the network, like network assistance, bitrate recommendation, delivery boost. You can set dynamic quality of service policies. You can get consumption reporting, quality of experience reporting, and so on. Let's say all what's available in the specs and the APIs that allow the applications to communicate with the networks. The repositories are all available in GitHub, and as you see, we are using different components, right? So there are components on the client. I mean, they are based on Android, but we use there are dependencies either on media players, also on API managing platforms, and then you can see here the logos of Open5GS because there are some tools that are like derivation of Open5GS network functions. And we are also using, I mean, since Open5GS and srsRAN, let's say there was a link, we were also using both, right? But that's to give an idea that our implementations are 3GPP compliant, and ideally we would also like to interact or to interop with other platforms, like for instance Free5GC or OpenAirInterface. That's highly relevant and really welcome. I won't go into details. The specifications are basically 3GPP. We develop the different network features, or let's say features that sit in the network side and also in the client, in order to bring, let's say, an application, right, that will be using the different components that the other organizations have been presenting. But the idea is to build this end-to-end system. So as you see, we don't touch a lot on NG-RAN, and for 5G core, we use what the network functions that are needed, but we develop the 3GPP specifications that sit more towards, or that let's say, towards the service provider and also on the client side. These are just pointers to what's available in the specs, and this is a little bit a map of the features and the, let's say, reference points and APIs that we are supporting in 5G MAN. There are tutorials available and there are demos available, right? So you can build all of this end-to-end, as said, using components from the 5G network and the NG-RAN that we do not develop, but we like to collaborate with others, and we would like to strengthen this collaboration also in terms of showing demos and so on. Just to show other projects, I won't go into details, but we have 5G core network components that are needed, for instance, libraries to service consumer libraries to communicate with PCF, BSF, right? Because there are some functions from the application function if you want to set up a quality of service policies that are needed. So we just develop a little bit like on demand based on the application we want to develop. We check what's available and we fill the gaps either by reusing components from other projects or developing our own, let's say, gaps to be able to use the system. So for instance, here we reused Open5GS components to develop these service consumers. We have also a project on UE data collection, reporting, and exposure, event exposure. So this is, if you go to a 3GPP specs, this is all there. So you have a client that collects data and that exposes it to the service provider. You can do this via NWDAV. We were not sure if there was an implementation ready to be used. I believe we've learned that some projects may be working on it, so that's very interesting. But in any case, the 3GPP specs also allow you to do this, let's say, with an application server that will consume these events or these notifications, right, without the need of using NWDAV. But at some point, we will also be interested in using NWDAV to expose these events to any other network function and so on. So it's just reference implementations, for instance, 26531, and this is all up and running. I won't go into details. We have other projects on 5G broadcast, MBMS, let's say, and its extensions in release 16, 17, 18, and now there is some work even in release 19. So we are supporting this. This is more like EPC based and UTRAN based. And for this, we started actually with the SRS LTE project. We started to develop some of the tools needed here to use MBMS in this sense with communication. So this is what has been developed and what is available, right? So we have some contributions that added functionalities to the existing srsRAN, right? So we can discuss at some point if that's useful for the srsRAN project, but at least this is hosted, and at least we acknowledge that we are using the different projects. This is what you can build, and so on. There's also, we work on support for emergency alerts over 5G broadcast. So basically to use this, well, to deliver SIP9 messages, not SIP9, SIP12 messages on the srsRAN platform to devices that are capable of, let's say, receive only without being registered into the network. So for this, well, we are developing some tools, but as said, we are reusing some of the components that are available, and we have integrated the SIP12 into this just as a prototype to do some testing and to show the functionalities, right? So all of this is available here, and we have been able to show the functionalities in different events and build demonstrators. As we work with multimedia technologies, there's a part that relates to protocols. I won't go into it very much, but we are we also support libraries, for instance, for FLUT, route for unidirectional delivery of media content, and there are also extensions to support, let's say, systems that come from other standards organizations like DVB that have developed certain profiles to interact with 5G systems. So we are also hosting some of these projects. We are now embarked into a bigger project, I would say, to enable MBS, and I'm not sure if this has been mentioned by any project, but we have started developing MBSMF and BUPF. Here, reusing Open5GS, but as I said, we are happy to collaborate with other platforms. This is just because, I mean, since we had experience, our developers had experience here, they took it. And we are also developing MBSF and BSTF, which is more like the 5G MBS user service part, specification from SA4 and 3GPP that are developing this. And we would like to extend this, right? So if there are synergies in any project that would allow us to speed up the development, I know there's also interest on NTN to enable this. We would be very happy to know and to collaborate. I won't go into the details. And then finally, other tools we are supporting are more related to immersive media. And here we are dealing with XR media, what we call XR media integration in 5G, but we have started with a scene description, right? The representation of the scenes that enable you, for instance, to realize augmented reality, virtual reality applications. And that's all defined also in certain 3GPP specs, and there's been worked in release 18, release 19 to enable all this. So what we are doing is basically to implement the 3GPP specs that also relate to MPEG to some extent, for instance, for these functions here. So here you see the 3GPP XR baseline client, and what we are doing step by step is to develop some of the components. At the moment, what you see, let's say 1, 2, 3 are the repos that we are supporting. And the idea is also to extend this, for instance, to include well, RTC or streaming, let's say, other architectures from 3GPP that support, for instance, realizing these use cases in terms of download, instead in terms of communication, or let's say from one side to another, or also like bidirectional communication between multiple parties in order to generate these XR experiences. As said, the contents of the repositories are available here. We have Unity Player, we have also an implementation of the technology that's defined in 3GPP and also in MPEG, and this is all, let's say, up and running. There's additional documentation here and also tutorials on how where all this comes from and how it relates to the 3GPP systems. And here you can see, let's say, some of the demos that we've been able to build with, let's say, the core network with a USRP, and also we've been able to display all these, let's say, tools related to 3GPP, MPEG, to support immersive media experiences. And then finally, and this is our most recent project, is the V3C Immersive Platform, which relates now to a feasibility study beyond 2D that is active in 3GPP. And basically it allows us to deliver, even to stream volumetric video content from, let's say, 3GPP network to end user devices. We started supporting smartphones, but we are moving a little bit also both for the XR and V3C project at some point. We also support head-mounted displays, head-mounted devices. So these are the repositories that implement all these tools. And well, in this case, the repos are private because there's some fine-tuning, but I'm sure we can shortly announce that they will be publicly available. As said, all the information and more materials are available on our website. I will circulate the slides and so on. But I want also to say that some other work we do is also to support the 3GPP standards, and we are allocating some tools also that relate to, for instance, evaluation frameworks for AI ML. I think there's now interest also from 3GPP to host some tools for beyond 2D. And we are also, let's say, collaborating with the SDOs in that sense to promote the technology and to also to support the standardization efforts by means of actual software tools and tangible assets that people can take to validate the specs and to build demos and products out of them. And with this, I believe, we conclude our presentations. I know there is no time for let's say, discussion and afterwards. I perhaps would allocate just 5 more minutes if there are questions from the audience that we can take online. But in any case, I make sure that we collect all the questions from the chat, that we put them somewhere. The videos will become available. I also want to receive, if you wish, your presentations from the different organizations. This has been, I think, a good first shot to understand a little bit where everybody is, but we need, I believe, more time to digest all what has been presented, and I hope it's been useful. I said, are there questions online for the participants here? Well, I think the chat has been moving a lot, so that's really good. If not, I would just like to thank first all the participants on the workshop. As said, some were not able to participate, and that's why we decided to record. And obviously, I would like to thank all the organizations, srsRAN, OpenAirInterface, Free5GC, Open5GS, for willing to collaborate in this initial one-shot workshop. On actual a little bit of short notice, I must say, but it's been great to have all you here, and I think it's been very useful to share all this information that we can digest afterwards and try to collaborate on projects, demos, and so on. So if there are no more questions, thank you very much to all, and I think we can close the workshop at this point, and we'll follow up probably by email. Thanks a lot.